Take the recording.
Hello and welcome to a special planning meeting for Cluster API. We're working on helping define the goals and requirements, and with that, for the next version. With that, I'm going to turn it over to Tim St. Clair.
So what I want to do in the very beginning of this conversation, I don't want to necessarily run this meeting, but I want to set up some ground rules for engagement, because last time we tried to talk about this, we kind of sprawled all over the place and had deep discussions about what our belly button looked like. So what I want to do in this discussion is kind of keep it focused. So Andy and I talked about it beforehand, and he's created two separate documents. One document outlines what are the broad level requirements that we are trying to accomplish. Then another document where folks can bike shed on use cases. And ultimately, what we'd like to do is collect enough use cases up so we can go back and forth and make sure that our requirements meet those use cases. But I think the goal of this first part of this conversation, and Andy can walk through the rest of this after this, is to talk about strictly the requirements. And if folks want to use a use case as a reference to define requirements, that's totally legit and makes sense. But I think what I want to avoid is the sprawling of the conversation, which goes deep into details about a specific use case scenario. Instead, I'd love to capture that in the other document. And then as we get further along, we can try to make sure that the requirements meet the use cases. Does that seem fair to everybody? Okay. I will hand it over to Andy then, and we can start to walk through the requirements.
Thank you, Tim. Let me get my doc ready for sharing here. All right, can everybody see the Cluster API goals and requirements doc? Awesome. So again, this is meant to be about goals, non-goals, and requirements. We can talk about use cases in a separate document, as Tim was saying. What we put down for some of the guidelines here are really about, as we look at these goals and we look at these requirements, do you think anything is missing? And as you look at all of these, is there anything listed in here that would prevent you or prohibit you from achieving your use cases? So we have a glossary up at the top, and hold on right there, I'm on the phone. We have a glossary up at the top, which we should fill in with additional things as needed. So I'm not going, well, I can read them. So provider, I know Clayton had a question as to, in one of the goals, we talk about provider agnostic logic. And so there was a question around what is provider. I think probably infrastructure provider here in terms of being able to provision machines and related aspects, but I'll fill that in later, or if anybody has suggestions, please feel free. We also want to have the concept of a control plane that is provisioned by Cluster API, where the control plane is represented either by machines or pods, but not something like a GKE or an EKS control plane. And then the alternative to self-provisioned is an external control plane like GKE or AKS. And we have been just brainstorming about potentially using Cluster API as a singular API to manage both external control planes and self-provisioned ones. Okay, I'm going to read off the goals as we have them written here. So number 1, to declaratively create, manage, and destroy Kubernetes conformant clusters. Kubernetes conformant just meaning that it can pass the conformance tests, and so it does not shut out vendors or other distributions. So Kubernetes, OpenShift, Rancher, whatever can pass conformance tests is what we're looking at managing.
Should we add that to the glossary up above? Because
Kubernetes conformant, sure.
Yeah.
I will fill that in later. Daniel, yes, this doc, I sent this to I sent a post to the SIG Cluster Lifecycle Google group. Okay, awesome. Okay, next goal, to work in different environments, both on premises and in the cloud. The third one here, which Clayton and I were having a comment discussion about, to consolidate common provider agnostic logic. We probably can get some better wording here, but the idea is that we want to make it so that the infrastructure providers that are provisioning machines don't have to write code that generates the control logic for running kubeadm init, kubeadm join, or anything else that you're using to do provisioning. And then the last goal that we have listed is around scaling and upgrades. So to manage groups of Kubernetes nodes as sets of replicas that will enable support for scaling and orchestrated upgrades. Any comments on any of these goals before I move on to non-goals?
Yes.
I'm just trying to.
Can we expand upon manage and what we think that means?
So I think when we were talking about it, it was mostly about adding nodes to the control plane, or adding members to the control plane, removing members from the control plane, adding non-control plane nodes, removing non-control plane nodes, and doing upgrades.
Should we say lifecycle somewhere in there? Because we're really doing lifecycle specific management. We are not doing other forms of Kubernetes management. So we need to, I do think wordsmithing is important and some of this stuff. So I can appreciate some of the people who are coming in wanting to understand the words. So somehow putting in words like lifecycle management probably would help a lot.
So, I mean, how about declaratively manage the life cycle instead of create, manage, and destroy?
Yeah. And then you could put that, you could put create, manage, destroy in parentheses. Which would be create, manage, destroy, upgrade, and autoscale? Yeah, I don't know if autoscale fits in that.
Well, so I'm not necessarily saying autoscale, but adjust the capacity of...
Scale is fine. Create, destroy, scale, upgrade. That should be the four main ones. Jason?
Possibly hibernate.
What was that, Hardik?
So possibly also hibernate clusters. So on a cluster, you should be able to. So for the development clusters, at least, we try to do something where we wanted to shut down, bring down few nodes and few of the control plane components for time being. Just we call the hibernate, and then when user wants to start developing again, he can just wake up the cluster, same state, he gets the same state back. So it's very easy to do with the given machine controller and so on. That turns out to be a very nice use case. We very heavily.
Isn't that a form of scale though?
Yeah, that's what I was going to say.
So just in one way, but then there would be, I think, more control plane components. I'm just thinking out loud that on top of the core Kubernetes control plane components, if you decide to deploy more control plane components, like one example is the machine controller, and if there are more deployments, like more tooling around the cluster API controller starts coming in, then we would probably want to reduce the cost of those pods or those controllers running if you can hibernate the cluster.
The thing that I worry about here is that we're talking how hibernate is a tricky concept, because can we ensure across all of the different providers that we're talking about the stability of IPs and things like that?
You can't. Hibernate's not consistent across providers. I know that deeply well. It's very different, right?
So I think it can be seen in a way that if I want to hibernate, I would basically shut down all the machines, and as long as as we see that if there are use cases where we want to maintain a control plane as such, I would also probably want to turn down the scheduler, controller manager, and all those control plane components which are not being used, and And when I want to wake up, I can again start all those components. Just my etcd and API server are running. Etcd is maintained, and I can get the entire thing.
Do we want to make the distinction between shutdown and destroy?
So this almost sounds to me like something that could potentially be at a layer above cluster API. If you're talking specifically about the control plane here.
I would recommend that, Hardik, if you would take some time when you have a moment and document hibernation as a use case in the use cases document. I think that's probably the best way to go right now. And in case you all haven't seen it, as Tim mentioned, we do have this separate use cases document. Everybody has edit rights, so you can just come in and add your use cases anywhere.
Yes, sure. And I unfortunately missed the first part of the disclaimer. When I joined, it was directly, are we fair with you? I guess I missed some initial parts of it. Yeah, understood.
I wanted to, Pablo, can you mute? Oh, thanks, Pablo.
So I wanted to just mention something about we were talking about the manage verb. So I thought, and we don't need to dig into this right now, but perhaps at some point we can set, a boundary for what the cluster API is responsible, or what configuration the cluster API is responsible for applying, by saying that, it's responsible for any configuration that must be applied before the initial control plane is up. And then once the initial control plane is up, that can be handled by tooling that's, just grabs a kubeconfig. That might make that manage term maybe a little bit more
could you potentially can you do suggestions on this doc?
Yeah, the permission's there.
If you want to put a suggestion for the language, maybe as a sub-bullet element there, I think that might be very helpful.
Yeah, I'll do that. Thanks.
Speaking of wordsmith, that first goal, I assume that only applies to clusters that are created using cluster API, not cluster created outside of cluster API, and that people would want to cluster API to then adopt.
I think that gets into the non-goals.
I see. Okay.
Yeah, we do have a non-goal about we do not want to manage non-cluster API provisioned clusters.
Andy, I have the question of if that's the case, how do you manage to manage clusters are provider for the cloud provider has managed cluster, like Amazon and Google? At some point, we mentioned that was a possibility.
Yeah, this is not saying we can't manage GKE clusters. It's saying that if we're going to manage a GKE cluster, it needs to be provisioned by cluster API.
Or the GKE would have to do some special stuff to make it look like it was, right?
Yeah, I mean, if you want to back your way into somehow creating the, I don't know, cluster machine, whatever the objects are, to represent the GKE cluster that you created on your own, if you can make that work, great, but it's not a goal to have cluster API automatically support that.
That would be on GKE or COPS or
somebody, yeah.
But not us.
Yeah.
Not cluster API.
Does that work, Pablo?
Sorry, I on the move. Yes, that works to me, as long as we at some point could probably say what it will take. I mean, if I wanted to do that myself, as a cluster provider, what the cluster API expect me to have? And it's like reverse the process of creation. Say, if you can, as you said, if you can provide a representation of your machine as machine object, and what else?
I think I think Pablo would probably help this discussion a lot, would be to outline your user story. So like the separate document where the use cases or the outlining your use case for that, we can go back and forth and try, after we finish talking about the requirements, we can try to see if your use case is met by the current list of requirements.
I like that, Tim. Okay.
So I have another, sorry, thanks, Wilson. I have another verb that we might want to add here, which is maintain. Because if we do still have this idea of a machine set or whatever that becomes, that if a node goes away for whatever reason, the VM is deleted or the hardware is gone, that maybe the cluster API tries to figure out how to bring a new node back into the cluster.
So if you see the requirement that I have highlighted, cluster API must take remediative action if Kubernetes cluster infrastructure is in a degraded state. I believe that covers what you're saying.
Sorry. Yep.
Does that also include things like, that, let's say the kubelet crashes, something file system level, it's not infrastructure layer, but it has to do with the node itself or applications or storage? Does that also, maybe I'm getting into the realm of like the node node problem detector space, but I'm just sort of curious here.
I think it's worth discussing. I don't know exactly what the breadth or depth is there. We had a few different variations for the wording on this one, but how about if we come back to it?
Yep, that's fine. I can leave a comment as well.
Okay, Justin?
I was going to suggest, I don't know whether it's a goal or a non-goal, but it's sort of I think one of the problems we have is there's this feeling that people have that we're trying to do everything. And so the goal that I'm proposing would be to integrate with other components in the ecosystem where it makes sense. And the non-goal would be to redefine everything that other components are doing. So this is specifically no problem detector. We shouldn't re-implement no problem detector. We should find a way to work well with no problem detector.
Even though I think it's superfluous, given the conversations, I think it's totally needed.
Yes, it's a shortcut, exactly.
All right, what was the wording you had for those?
Do we want to do it as a goal or a non-goal?
So I feel like there's kind of, around the non-goal here about forcing Lifecycle products to support or use these APIs. I think there was some discussion in the KEP from months ago about, maybe these Lifecycle tools want to start adopting portions of cluster API piecemeal as they have time and as it makes sense. And I think that kind of touches on what you were saying, along with things like Node Problem Detector and other tools in the ecosystem, that it would be nice if there were, if we were just thinking about integrations up front.
Yes, so I guess to integrate with other ecosystem components, I don't know. Such as
I'll write it down and I'll put the Node Problem Detector as an example and we can wordsmith.
To avoid replicating functionality of existing components.
So I think there's a line to walk here too. So for example, it would be great to integrate with the cluster autoscaler, but there is some behavior in the cluster autoscaler, specifically determining which node to remove from the system, that it may make sense to either adopt or import into cluster API.
Well, I mean, for that case, the decision of which node seems like it's squarely in the domain of the autoscaler, which has knowledge of metrics and things like that. But the actual, the actual deletion of the node would be something for cluster API, I would think.
Well, the reason why I say that, though, is because if the autoscaler is using those to determine which node to scale up or which node to scale down based on, that might make sense to also be able to do that in the case of a manual scale down in cluster API.
Right. So cluster API would need to support a way that you can say scale down this particular node, but then you could do it manually or you could do it from the autoscaler.
So why don't we table this particular one and highlight that last line that Andy had just added, and it needs to be expounded. The language needs to be wordsmithed a bit more, but I think there is a fine line of minutia here about it's okay. We want to, as you said, we want to integrate where possible, but we don't want to preclude ourselves from doing what we need to do to get our job done. So there might be a portion where we might define scale behavior that is not in the current autoscaler.
Mm-hmm.
And that should be totally fine for us to do. Mm-hmm. We are outside the core, right?
So I think that's your mention of core is a good next topic. So this non-goal is a paraphrase of what's in the KEP, and it's to add these APIs to Kubernetes core. And I know there was a decent amount of discussion over here with Clayton about what does this actually mean, and does it involve API reviews? And
Clayton makes an excellent point in that we have a bunch of CRDs that live outside of Kubernetes proper, but they use the k8s.io name. And we should probably have a distinction for things that live in the sphere that's outside the core, but we actually haven't given taxonomy to that. So I think it's totally legit. His statement is legit in that, like, we should define a namespace that is outside the core that lives underneath this larger umbrella that we would love for the API reviewers to come in and give us feedback, but it's not strictly required for us to release, because again, this is not a requirement for you to run Kubernetes. This is a thing that helps people that they have to opt into, right?
But don't you think that anything coming out of the Kubernetes organization should follow at least the API conventions and do some API review type of things? I mean, we don't want to be building APIs out of a SIG that are completely in conflict with the overall.
I would love review, but if they're totally in conflict, I would argue that, like, we were doing something fundamentally wrong.
Exactly. Yeah, I agree.
Somebody is somewhere.
I think the balance too is I don't think at this stage of where we are with Cluster API, it makes sense to block development waiting on API reviews for all of the API changes that we're looking to do. Now, when we talk about going from alpha to beta, that may be a different story. We may want to actually seek a more formal API review then, but iterating on alpha seems a bit heavy-handed on process.
Definitely.
Well, API reviews right now today are totally blocked by only a couple of people. So the notion of us that is external to the core being blocked by reviewers, it would grind the project to a halt, right? Because the sheer volume of CRDs that exist outside of the core of Kubernetes is an order of magnitude larger than the core of Kubernetes itself proper as it exists today. And so I just want to make sure that there's minutia there, and we should have some distinction, and we should refine our current API review process.
Yeah, especially around alpha APIs. It doesn't make any sense for people to be reviewing iterative alpha APIs.
Exactly.
So do you all think that the language here is appropriate, or does it need to say something more about we don't want to be blocked on API reviews by the Kubernetes API reviewers, or I don't know.
So I don't think we need
point that. Go ahead, Jason.
So I don't think we need to do that, because the original non-goal here was to say we don't intend this to be part of the proper KK deliverables.
Yeah, and I think there's a good point in that there should be a taxonomy for defining things that are outside the core but are on the periphery. And we ideally want to have feedback, but we also don't and shouldn't be blocked, right? So
yeah, it almost seems like we need a namespace where we can put like SIG-owned projects similar to like the governance around the SIG subprojects.
Yeah, I think APIs should have that model as well, because we do that within the whole structure of GitHub repositories. So having a sigs.k8.io makes perfect sense to me. But I think that's another discussion, and we should totally take this up. I'll take this up in architecture next week.
Okay, thanks, Tim. Okay, the next non-goal is to manage the life cycle of infrastructure unrelated to the running of Kubernetes conformant clusters. So we don't want to become generic Terraform, create anything you can do in any cloud provider. And I thought this was fairly straightforward, although there was some discussion back and forth between Clayton and me. But I think this wording hopefully will work for everybody. If not, feel free to add some more comments. I already mentioned about not forcing Kubernetes lifecycle products like Kops and KubeSpray and managed Kubernetes providers to support or use these APIs. And then we also touched on we don't want to manage clusters that were provisioned not by cluster API.
So one thing, you touched on this topic about having kind of a on-ramping path for projects that want to adopt cluster API. Should we specifically call that out as one of our goals?
I think that's fair. I'm trying to figure out what would be some action items, whether they're requirements or use cases that would stem from such a goal.
So when we get into the requirements, it could be such that, creation of a machine doesn't require, the specific, because right now when we reconcile a machine, we pass in a full cluster object, and that cluster object is, we introspect data from that cluster object to get shared config. It could be that, we force ourselves to design a more explicit interface around the machine that doesn't require that kind of external object.
So something like to allow Kubernetes lifecycle products to adopt portions of cluster API as they're able to, or something like that.
I don't know if I would call it out that way, or maybe it would make sense to just say that we should have a staged adoption path for.
Perhaps if it's okay if we can't agree upon wordsmithing, I think maybe prefacing some of the statements with AI : will help us to revisit it and maybe get suggestions from the broader group.
I'm just going to do that. Wordsmith. Does that work?
Yeah.
Works for me.
All right. So that's it for goals and non-goals. Any other comments on them before moving on to requirements? Okay. I'm going to go top down. Number 1, cluster API must be able to be deployed to run on Kubernetes. Hopefully that is not controversial. Please speak up if you do have something to say. Otherwise, I'm just going to keep on going. So number 2, cluster API must support multiple providers. And again, the definition of provider is a little bit loose at this time, but it's meant to mean infrastructure providers. So where you're getting your machines and related infrastructure. So this one might be a candidate for wordsmithing. Next up, we must have conformance tests to ensure that cluster API and a given provider fulfill the expectations of users/automation.
Conformance style might avoid the whole is it conformance thing.
So you're talking about cluster API conformance?
So
Yeah.
I think the wording used it should be validation. That's the wording we're using in SIG Arch around things that are are conformance. So validating tests.
Well, they call it, specifically in the conformance group, it's called profiles. So this would be another profile. It'd be a cluster API conformance profile. So there's a.
Well, we haven't settled on, I mean, I think that like there's node validation tests. It's sort of just a more profile. I think we haven't fully defined that yet, have we? I mean, it's kind of.
Well, we have taxonomy. We have a very good framework by which we haven't specified it. So we've laid down the taxonomy, but we haven't been explicit about it. So maybe wordsmith that one. And
yeah, I think the intent, I'm guessing here, is given a release of cluster API and a provider, if you install and deploy them, you must be able to do a standard set of things, which we're calling conformance, which is probably create a cluster. On that cluster, I can at least run a pod, and then I can delete the cluster, like something like that.
Oh, so it isn't defining new tests. This is saying that we have tests that verify that the cluster API implementation, that the cluster that is created satisfies the existing conformance tests, whatever they may be.
Well, I think there's two aspects to it. So there's like, do the providers work with cluster API? So let's pretend we have gRPC based providers. So if I deploy my provider, is it implementing all the right gRPC services, and do they all function? And when I ask for a cluster, do I get a cluster? So that makes sure that the boundary between cluster API and the providers is functional. And then there's also the standard, as we know them today, Kubernetes node conformance or conformance tests that we probably, like, they should probably pass when you spin up a cluster with cluster API. But I think they're two slightly different types of tests to be running.
Yeah, I think that those are two different things. I think that the conforming of the resulting cluster is already covered earlier because it says somewhere that a conformant cluster. Maybe when we say should deploy a cluster, the conformant should be in there. But as far as validating that the given provider implements things properly, I guess there's also a validation in the other way of, and this probably doesn't need to be in here, but when we rev a version of cluster API, there's some sort of expectation of backwards compatibility for providers, but that doesn't need to be in here.
is there, I want to make sure that everyone realizes they should have suggestion rights. Wordsmithing is a group activity, so if you can think of a clever way of stating the same thing, my wife is an expert at deciphering Timisms. So I'd recommend maybe taking a stab at it if you have some clever ideas to put below. Maybe we can do like a bullet point list below of potential ways to phrase things. So if you put suggestions down below that, instead of us going ad nauseum here, we can have folks do it asynchronously.
Thanks, Tim. Okay, next one, cluster API must not. Yes?
Sorry, this is Alberto. I wanted to make a point regarding the conformant testing. I think some of the discussions that we are recently having are in part because there are a lot of ambiguity today. So I think it'd be great if we can crystallize some of the goals and known goals in the form of end-to-end testing eventually. So this would help to have to codify kind of the goals. So I don't know if that makes sense.
Yeah, I'm not really sure what you're looking for specifically.
Like what I'm trying to say is that eventually it would be great if we manage to materialize and represent some of these goals in the form of end-to-end testing. So this way we can remove some of the ambiguity that we have today in the project, because this would be basically codified, right?
Okay, so, yeah, I think you're restating what we have here about we want to have, or we must have conformance tests to make sure that cluster API and providers work properly.
Yeah, I think he's explicitly stating that, like, typically, if I'm super old school and I designed a specification, I should have a test for every spec that I write. So everything that has a must has a test. I think that's
exactly. That's the idea. Thank you.
Okay, that makes sense to me. I don't think that there's any change we need to make to the document for that, though. Is there?
I don't think so.
Hold on. Okay, so yes, next up, cluster API must not have in-tree provider code. I hope that's not controversial. Then cluster API must be able to create clusters on multiple providers through a single deployment. So I think this is, if I have deployed cluster API in one place, then I can create my machines and clusters and whatever other CRDs we end up with in that one place and have them run on AWS and GCP and all over the place without having to have separate separate management clusters, I guess.
The one thing that wasn't clear to me, so this is specifically, does it include or exclude cross-provider clusters?
I don't think we should try and do cross-provider clusters.
I agree, but with the current wording, it's not clear whether or not.
Are you saying like so when you say cross-provider cluster, do you mean I've got a management cluster running on AWS and it's spawning clusters in GCE?
No, I mean managing a cluster that, a single cluster that's managed by cluster API that spans multiple providers.
Like machine deployment, 2 different machine deployments, one in AWS, one in Google.
Yes, I agree. That would be dangerous.
The networking would just be really hard.
So that's my wordsmithing. The intent was to specifically exclude that. So if there is better wordsmithing, please wordsmith away.
But this is implying that one cluster API can manage. It's not just managing the cluster it's in; it's managing many other clusters.
Yeah, and they might be on different providers, but it's not a single cluster across multiple providers.
When we're talking about, I think now we've reached this point where we're talking about the case where we're not pivoting, right? Where we have the management cluster, and then Mark from Weaveworks used the term in a implementer's office hours as a workload cluster, and that seems to be a pretty good term. I don't know if maybe we could adopt that to when we're referring to the cluster that is being managed.
Yeah, I definitely agree. We need something to call it. Workload cluster, provision cluster, something along those lines. So I know, I guess we had this one here about managing clusters on multiple providers, and then we got this new one about creating clusters on multiple providers. I don't know that we need 2 requirements for this if we maybe combine them as our lifecycle management discussion that we had earlier.
Yes, I agree.
Okay, let's see.
So there is a comment on that second one.
Yeah.
And I'm not exactly sure what Derek is asking there. Unless he was thinking that was related to spanning providers with a single cluster.
My interpretation is he's just, we can ask him in like 15 minutes or 18 minutes, but my interpretation is he's like drilling in on manage and not multiple. So like, is etcd backup included is one that he has mentioned before as a task, which to me would
Yeah. And I think maybe we should just be explicit, and every time we say manage, we should say lifecycle manage, or just explicit is better than implicit, especially with people who are new coming into this space. So let's be explicit there.
We have up here: create, scale, upgrade, destroy.
CSAT.
So for this one, Andrew, was this just a suggestion for how to reword it, I think?
Yeah, exactly. Yep.
All right, so.
I'm not sure that that's the same thing, though. Using an identical deployment implies, an identical specification implies some abstraction that I don't know that we want to do. A single cluster API, you may create a cluster that's on different providers, but not necessarily using an identical resource definition.
Right, yeah, there'll be some provider-specific extensions probably, right? So that's a good point.
All right. Okay. Are we good to move on to the next item here? All right. So cluster API must provide information as to which versions of Kubernetes it can manage. And this is the first of several where we have can opt out and or change implementation. The intent here is that if I'm an end user, I would like to find out when I go to cluster API, can I use you to install Kubernetes 113, 114, 112, whatever? And the opt-out and change implementation part is about trying to support multiple distributions and vendors.
I personally find this one challenging. Like, would docs satisfy this requirement, or are you talking about some sort of API or feedback if you just do it wrong?
So I'd at least like to explore the option of an API.
So if it's opt-out, should we not have must there? If it's must, right, if we're going to define an API and say you must implement this API, then...
So I think the reason why we added must there was that for using kind of vanilla upstream cluster API, this would be a required feature. But for vendors and other tooling that is looking to leverage cluster API, say like Kops, Kubicorn, OpenShift, or some other type of productized version, they could choose to opt out and or modify the implementation.
I mean, I don't see it as a big deal to comply with this in terms of like, if we agree a CRD, like I'm sure everyone would happily fill it out. I just worry that it's...
So the language you use is be able to, so it must be able to provide. It doesn't say it must, it shall provide. So like the language you use above, if you're being consistent, and then it would nix the entire can opt out, because be able to means that it's not strictly required.
I mean, from a usability perspective, I think this is a valuable feature.
I agree. We need to be able to have things that some providers that they have the ability to be optional, and that would be like the optional field in the spec for the API itself.
So maybe we need to come back and make slight revisions on must and opt out and whatnot, but at least for the intent of the requirement here about being able to find out what version or versions are supported, that's what we're going for.
I mean, it seems like we're talking about two different things at the same time, and that's part of the confusion. We're talking about the specification of the API, and then we're talking about provider implementations of that specification. And we're saying the specification must include this API call, but people may or may not implement it. But we want vanilla sort of reference implementation to implement it, something like that. It seems like maybe we're mixing requirements of 2 or 3 different things here.
I agree. If we really want it to be optional, we should probably say may. Cluster API may provide info, unless we don't want it to be optional.
So the problem is that we have multiple use cases where Cluster API sits in. One is the pure upstream. I want to be able to leverage Cluster API to be able to stamp out kind of upstream vanilla Kubernetes clusters. And then we have all the various different types of Cluster APIs and implementation detail of use. Whether that's like a managed service provider that's providing Kubernetes as a service to users, or it's some existing type of installer or management tooling that wants to adopt Cluster API, or any other type of high-level tooling that would want to use Cluster API and provide a much more kind of opinionated use case from that. So I do think we need better wording around the upstream implementation must be able to do something versus something that should be able to be opted out of by downstream users.
So I need to open a book here and go back to it, but like I think let's do the wordsmith thing and keep on moving. Still, I think we have the right idea in the shared context in this conversation, but the language is escaping us because we're engineers. But there are books that actually help us to accurately represent what we're stating.
I think related to that, I think this one is different from the others, I think, in that if we can come up with a great API, no one is going to object to us doing this. This can be a goal for us, but no one is going to, as far as I know, no one is likely to say, you can't do that, that's like our turf. It feels, we're debating whether or not it's achievable, but we can aim for it.
Good point, Justin.
So the question I have is this the next release, a requirement for the next release, or just a long-term goal?
Nothing here is scoped to a particular timeline.
Okay.
Right now, we're just trying to be aspirational. So to crisp up the conversation in particular about what is Cluster API, what is in scope, what is out of scope.
Okay, moving on. Must be able to initialize and configure a new Kubernetes control plane, again with swappable implementations. So the thinking here is most likely decoupling machines from configuration of what's on there, and maybe we have some config API. I don't know what it would look like, but we do want to have the ability to bootstrap a control plane and allow people like OpenShift or Rancher or whomever to have their own implementation.
I would explicitly say bootstrap and get rid of initialize configure. If we're being, especially the configure one is ambiguous.
There.
I almost feel like it's more than bootstrap though, because this would basically take over the life cycle of that control plane.
Well, we have scale up and down the control plane, and we have upgrades. So if you put the 3 of them together, that should be all of it, right?
Well, except for delete.
Sure.
So here it looks like the can opt out was copied from the above, but I don't think that something could opt out. Like maybe we have implementation hooks, but this seems like the core of Cluster API.
So if we do want to provide like a staged on-ramp to Cluster API, I think it does make sense to allow somebody to adopt the machine abstractions before adopting the cluster abstractions.
And one way to do opt-out is to provide a no-op implementation, basically.
Can somebody put a bullet point and describe that below, because it's really not intuitive from the first pass.
Sorry, I forgot the wording that you used, Jason. It was like
for users that want to or like existing consumers that want to on-ramp onto Cluster API, being able to adopt the machine abstractions before adopting the higher level like cluster abstractions makes a lot of sense.
I mean, again, I think this is where cluster API is too broad of a term. Maybe we should be taking requirements of each of those individual functions.
You would define, yeah, if you were defining requirements, you would have the cluster API, which is legit, and then you'd have the, the machines API if you want to lump that all together.
So right. I think once we can agree on what the scope of the project is and what kind of, as we start diving into it, it may make sense to break those out and scope those individually. But right now, I think we're still talking about the holistic project and not necessarily, like, I think decomposing it at this point is probably premature.
And everywhere we wrote cluster API at the beginning of each of these requirements, it's not about the cluster API group in API machinery. It's this project, the scope of this project.
We should put the reference in the glossary about I wouldn't even change the glossary to be taxonomy because it's how you're using the words.
Sure. I'll get around to that.
Sorry, I want to ask something. Sorry, because I was in a very noisy place. I could not speak at that moment. Before, when we were talking about the ability to bootstrap and configure a cluster using, let's say, external tool, what is the result of that from the cluster API perspective? What we get back?
We've explicitly said non-goal.
Okay.
We said, like, if it's non-cluster API deployed, then it's a non-goal of the cluster API to manage that.
But just before we were talking about provisioning the control plane.
So Pablo, do you mean like cluster API provisioning and managing, like managed Kubernetes services like GKE or?
No. Just a minute ago, we were discussing this of using this other tool for bootstrapping and configuring the control plane.
Oh, we're talking about hook. Essentially, we're talking about hook-based mechanisms.
Okay.
As well as we're talking about using a subset of the API. There's two different parts.
No, okay, no, sorry. It's just, okay, you say we still are in control of the process, just at some point we had a hook or something mechanism that we can interface with external elements to configure the control plane. Is that I don't really get the idea of this bootstrapping, configuring the control plane. What it really means.
So at some point, we will have a machine, whether it's VM or bare metal or what, that is created, and it needs to be configured such that it can run Kubernetes init or whatever you do with other distributions to get them initialized. So it's about making sure that when you have a bare operating system, that you can configure it so that it runs Kubernetes.
And this is where I think that the hook is important, because I'm working on an implementation of Cluster API that does not assume that there's a machine or a VM. So I just want to make sure that we keep the idea of hooks in mind.
Oh, yeah. So we haven't really talked much about design today, but in the discussions that we've had when working on some of this content, we are very much in favor of extension mechanisms with hooks, gRPC, webhooks, whatever it ends up being.
Awesome, great.
Do we want to take a break before the next session starts?
I think that's probably a good idea. So there are going to be people joining most likely in a few minutes who obviously we're not able to attend this first hour. I'm tempted to start back at the beginning for those people who are new, but obviously anybody who's on the call for 2 full hours would be hearing the same stuff over. So what do you all think?
What if we gave someone the task of summarizing what we had decided and agreed in the first hour, and if anyone has any vigorous objections, they can raise them.
That works for me.
As long as it's not me that has to summarize.
Well, I mean, the summary is basically, we talked about a bunch of stuff. Here's the ground rules. Watch the recording for the debate.
Is there anyone who's really good at wordsmithing and spec writing? Like, let's solicit the group here who, like, I do it begrudgingly, but I also do it in a slightly different way. But I don't particularly want to own this. I purposely trying to like make sure I help guide people, but I don't want to own the language. So is there anyone on the call who's really good with writing specs?
I mean, I'm happy to write stuff, but there may be some confusion in my wording.
I thought we were going to take a bullet point approach to this, so that people can just throw in their version of the wordsmith, and then we can choose the best one.
Yeah, maybe we should. Yeah, each person should. But
yeah, I agree. But
we should just say something in the document, and we can decide what accept.
But it's one of those things too, though. If everyone's responsible, no one's responsible. So, like, if somebody takes point or takes leadership on it, I think it'll help drive it over the finish line. I saw David unmuting, so I'm looking at David now, hoping that he wants to.
Can you guys hear me?
Yeah.
Yeah, we can now.
Oh, okay. Yeah, I may not be good at it, but I'd volunteer to distribute.
Way to jump on the hand grenade, David.
I have a suggestion for the for the people that are going to be joining. Is can we demark where we finished in the first hour in terms of working through these different areas? That way, people know what they need to go back to watch. Thank you.
All right, I will be right back. I need a quick restroom break.
All right, I'll go ahead and I'll stop the recording and then, or pause the recording, and then we can pick back up shortly. All right, back to you, Andy.
Okay, or actually, Jason, do you want to do the intro here for the recording?
Oh, I just paused it, so this is the same recording.
Oh, great. Okay, so for those of you who are just joining, we have been going through the Cluster API Goals and Requirements document. This has a lot of the content from the giant What is Cluster API document that was previously shared with you. And just in terms of guidelines for the discussion, we want to have a separation between the goals and requirements and use cases. So we have a separate document. Everyone has edit permission on this use cases document, and we encourage you to add your use cases. There are not necessarily any wrong answers here, so it's definitely worth putting them in so that we can see what people are interested in doing and we can talk about them. But for this discussion, we are trying to stay at a high level with goals and requirements, and we're trying to see if there's anything missing for goals and requirements, and if anything that's in this document would prevent you or prohibit you from achieving what your use cases are. So we've been working on a taxonomy that is in development in terms of the terminology that we have in this document, so that hopefully we can all have a single common language. And we have been going through the goals and non-goals and requirements, and I would say basically there's places where we have wordsmith written in front of something, and that's where we've discussed it. We understand the intent, but the wording might not be great. So what we'd recommend is that you go into suggesting mode and add some bulleted ideas for how you might reword either the goals or requirements or phrasing. And I think we decided that we were going to just pick up with the requirements that where we left off at the end of the first hour. And for those of you that are joining, if you want to catch up while we're having the conversation, feel free to read through the goals, non-goals, and requirements above this end of hour 1 line. And when there's a break in the conversation, please feel free to bring up any of the items here so we can have additional discussion on them. Does that sound fair? I'll take that as a yes. So the next requirement we were going to look at is cluster API must be able to provide a consistent way to prepare, configure, and join nodes to a cluster across providers with the ability to opt out or change implementation. So the intent here is that we have common logic for basically calling kubeadm join or the equivalent, and that if you're not using kubeadm but you have another way to do it, that we have an extension mechanism so that you can supply your own way to do that.
Is this requirement separate from provisioning the underlying compute? Like, does this requirement hold on if I had pre-existing infra?
I think so. If you have pre-existing infra, presumably you would use remote execution or some. You certainly wouldn't be using like Cloud Init to do that because it's after first boot, right?
No, I might have a physical computer in my data center. I'm asking if I guess I'm just trying to understand, like, is this after a machine exists or does not exist in the world?
I think it does.
We haven't gotten into the details yet. When we've discussed it, we've discussed about having to support both use cases, both the pre-boot config injection a la Cloud Init, and then post-boot, also support post-boot for like remote execution based. But this was more at a high level, just saying that we should be able to standardize and centralize the config across providers so that it is no longer a provider-specific implementation detail like it is today.
Yeah. Are each of those steps prepare, configure, and join decomposable? So, right, I set up a node myself. We have a requirement for that, and then I can just join it. So I can do the prepare any way I want. I can do the configure any way I want, and then I can use the join phase. Or are these a unit?
So I mean, I don't think we've defined that yet because we're still talking at high level. But I mean, if you're providing the infrastructure in some other way, you can pre-configure that however you want before giving access to it.
I would say this is one that definitely needs wordsmithing and clarification.
Yeah, I think there's certainly a little bit of like, I mean, we don't have a very specific language around these things, and even like in terms of, you know, which providers do assume that there are some machines that exist, which providers do call out to some APIs in an IaaS environment where, you know, that those APIs result in some machines coming up. And, you know, just like we like a language there, I think, really. And some people assume that, I mean, some people want to use like machines that start up from images with everything pre-installed. Some people want whatever the cluster API provider to install everything that is needed. And there are all sorts of different scenarios there. And I think we kind of lack the language.
So I think that's where we were going with the should be able to opt out and or change implementation so that, you know, if the default implementation does not meet your needs, you should be able to specify an alternative implementation.
And so, what do we call that layer?
Ilya, what we've been doing is if you have questions or comments, to add sub-bullet elements as suggestions about how we rephrase this or other issues that might come along the way. Because we recognize we have a deficiency in taxonomy. And part of this process is, especially with people coming online that are relatively new to this space, is that we realize that there's overloaded terms that people are using, and we need to be more explicit with our taxonomy. Although some of us old timers, like Justin, Santa Barbara, and Jason, and myself, can just look at each other and know what we're talking about, that doesn't mean that it makes sense to everybody else. So it would be helpful for the broader group to try and document in the sub-bullet items what your thoughts are, and then we can try to refine that.
Sounds good. Yeah.
So, Tim, I appreciate that and second that. I could just so like taxonomy though, does join include CSR approve?
It could. It depends upon how you're doing it, but it could. Inside of Kubernetes, it does.
It seems that the expectation is that a node appears. You cast the spell and a node appears, and the details of how that happens are down to the implementation.
Yeah, I think the other thing to note here is we're talking about high-level kind of requirements at this point, and after we can agree on the high-level requirements, we will then further dive down into the actual implementation details later on.
Exactly.
Yeah, I think that's good. I just want to make sure I understood what was meant by join.
Yeah, so join would be when you run kubectl get node, there is a ready node that you can get pods running on. All right, shall we move on? Next up, Cluster API must be able to scale up and down a self-provisioned Kubernetes control plane with a swappable implementation. Self-provision meaning that Cluster API was responsible for creating the control plane, and this is to call out a difference between managed services like GKE, where we likely won't have any control over the size of the control plane.
So it might be worth it for the people who joined earlier to go back to the earlier bullet point around spinning up the control or bootstrapping the control plane.
Were you talking about this one or the goal?
2 down.
Oh, right. Sorry. Yes, so related requirements, one for bootstrapping a control plane and then another for scaling it.
What does it mean to scale a control plane?
Add
Additional members to it.
I think you mean not the control plane, you mean the actual workload cluster, right? The control, not scaling the control.
No, this one specifically around the control plane. So if you're going to go from a single control plane instance to a multi-control plane instance, encapsulating what's needed to safely scale up or scale down the control plane.
Yeah, so just to clarify that then, so that it is the choice single node control plane versus HA node control plane, or HA with opinionated placement, or HA with a minimum number of nodes, or is it just the concept of?
We haven't defined that yet. We're just saying that this Cluster API as a holistic project should be able to spin up a control plane for you, whether that's instance-based, pod-based, or through a managed Kubernetes service. And then in this case, it should be able to scale up or scale down safely that
so that you can handle larger clusters, you're saying? Like scale, if you want to handle a larger cluster, you need a control plane running on larger infrastructure or more infrastructure. Is that, because
yeah, or just HA enablement, various.
A common example might be like you started out with a one node environment, which started out as your dev environment, and you want to grow it to be more production ready. Maybe it becomes a staging not necessarily prod, and then you evolve it over time. That's really common for people who, they start small, they work on it, and then they have more requirements over time.
Well, it's also, if I'm going from nothing to I want a production ready cluster, I assume you're going to start with a single control plane instance, but that's not sufficient. So the scaling up here is I've got my one member, and now I want to add members 2 and 3.
So let me tease this apart a little bit. So not every cluster API provider would want to support a non-HA control plane. And I could see other cluster API providers would want to allow granular options on non-HA, HA, as well as regional. So rather than refer to your control plane relative to number of machines, should we refer to it more around its characteristic?
So I don't think we've defined it in any way other than, so we could reword this in a way that makes more sense.
Yeah.
And doesn't necessarily imply that it's just X number of instances.
Yeah, I think that's fine. I think I typically would describe control planes in terms of HA, not HA, or regional, and not scale as a word.
Well, that's part of this discussion. So people that have been working on it for a long time would just use scale because it could mean any of those. Part of this, if you have better taxonomy, by all means, please give a suggestion, because there's a section at the top. But trying to get people who are new and old timers on the same page is going to take a little bit.
Okay, sorry, it was mentioned earlier. Is this supposed to be applied to clusters where, GKE type use cases, or is this fully self-provision? Right, we use self-provision. Okay.
Yeah, if for some reason a managed Kubernetes provider does expose that knob, then sure, we could twiddle the knobs for it. But in general, this is for components that are managed specifically by cluster API.
And we should say, provided we should have some clause there that says provided the deployment or whatever the tool, the hosted offering, whatever you want to call it, supports that capability.
Yeah, but isn't it like sort of? I'm thinking, I could say that my provider gives you a choice at the start, and you can't move away from that choice. And if you chose a non-HA option at the start, you'll have to rebuild your cluster with a HA at the start. And if you chose an HA, then you can scale it up.
Yeah, that's why I need the clause that provided that.
Well, I think that's why we scoped it down to self-provisioned control planes here, because we didn't want to get into the minutia of specifically around the managed providers.
Well, self-provision
by the managed provider now.
By cluster, it could be provisioned by cluster API though still. So it is self-provision.
So when we wrote this, we meant self-provision to mean I've got some machines that cluster API put together, and you're going to start with your single member and add more. And we were not, self-provisioned here was not meant to be or to apply to GKE, for example.
Yeah, understood. Yeah, thanks. Yeah, I was actually thinking in a case of a actual self-provisioned control plane, a provider implementer may choose that a single node control plane is done in such a way that it's non-scalable, and they only allow you to scale if you started with an HA control plane, and you could just go to 5 SCD.
So one of the things here, Ilya, is that we're trying to centralize a lot of the logic around management within cluster API directly. So it's not a provider-specific implementation on how control planes are managed versus things like that.
Okay, that's good.
All right, so I would recommend that if you have additional comments or questions or wordsmithing on this one, please feel free to add bullets below or comments. The next topic is that Cluster API must provide high-level orchestration for Kubernetes upgrades. Again, hookable, swappable from an implementation perspective. And this would apply to an entire cluster, so control plane and non-control plane members. No comments, other than I see Daniel's got some suggested text here.
I'm sorry, and this was the must provide high-level orchestration for kube upgrades?
Yes.
Is the orchestration at a level of desired state or mechanism?
So I think this is going to be something like many of the items that are in here, we will be breaking up into groups to talk about implementation details. I would expect there to be a reference implementation for upstream Kubernetes, and other providers could do different implementations, either for upstream Kubernetes if they want to do it differently, or for vendor distributions as well. Does that answer your question?
Yes, I think so. And does this include components or assume management of etcd, DNS, kubeproxy, or add-on components like auto-scaling?
So we had... What's that, Jason?
I was going to say to be determined.
Okay.
Yeah, we had a discussion in the first hour about when you're managing a cluster, is there a definition of a configuration that has to be there for the cluster to be considered minimally functional, and that if there are add-ons, we could figure out that later. I know that your questions around add-ons are, I know you have a lot of questions about them, and I don't know that we have all the answers.
I think, well, it's been very explicit for us that we call them core add-ons, and it's part of bootstrapping. So inside of kubeadm and the add-on management conversation, which has been ongoing since, I don't know, Justin, forever. So those are considered core add-ons. That's part of bootstrapping. So we lump it into bootstrapping. So everything that discusses bootstrapping is that piece. Everything after that point is considered add-ons that are non-essential. So if you see bootstrap, that means things that are core add-ons, which includes things like core DNS and the proxy. If you see anything else like Heapster or whatnot, that would be not essential. That would be after the bootstrap process itself. We don't go into that space at all.
And does the networking fall into core or the other?
It does. That's one add-on that's a little bit fuzzy. So it's post-bootstrap that you need to do one more thing. We've debated actually several times whether or not CNI should be a separate step, but you don't get something functional. So we want to put users, it's that weird boundary line where we want to get users in a good space. So the CNI is usually kind of predetermined or semi-baked in by the provider specific configuration with options or knobs to specify, right?
Yeah, I don't think we can escape CNI completely, because then we wouldn't be able to validate that we have a conformant cluster.
Right. Yeah. Yeah. I wonder whether that makes, potentially makes CNI more important and critical, and we should kind of consider it being less of an optional thing, because now it's like it's sort of in between, right? Maybe that makes the case for it to stop being such a thing. And and become more first class. I don't know what exactly that would mean though, but yeah.
Tim, is there another way I could phrase the question, which is, and help me here if I'm off. So, like in QADM today, like you talked about the core add-ons, and I think you said something like metric server was probably not one of those. When we describe add-ons, do we describe them in terms of the function they provide in the cluster API, or in terms of the actual implementation choice? So for example, if cluster API wants to manage DNS, does it make the choice of which DNS solution is used? Like, or is it just more the, I would like a way of saying, I just want DNS?
So we don't explicitly make that a cluster API knob. That's not really in the core cluster API itself. We've kind of escaped this by making that provider specific. And so long as it creates a Kubernetes conformant cluster. Now we do realize that we need to kind of dedupe the universe. That's kind of why we're having parts of these conversations, is to figure out what belongs in cluster API versus what things have federated out to the providers. And how do we make this common scenario clean? And I don't think we have a specific answer for that, other than we should allow the customization for things like CNI. We know that to be true. I think we're lacking the vernacular to make it clear to everybody who's kind of new. So I don't know how I distill that into a requirement, other than we're trying to dedupe things. But we should probably be explicit on like what things are optional for the cluster API as we start to get to this deduped world.
Yeah, and I guess my preference, and I don't want to speak for others, but I would prefer we describe things in their characteristic rather than their implementation approach. And so if you're saying I would desire a cluster that has DNS, I think that's different than saying I desire a cluster that has core DNS.
So to be clear, as we've discussed, like bootstrapping the cluster and the control plane and the nodes and all of those things, you know, we've left it so that we want those to be explicit extension points that can be either opted out of or overridden. So just because something exists in the kind of standard default configuration doesn't mean that that's the only way to consume it.
Okay, thank you.
Okay. And is CRI implementation somehow a thing we should be considering here? In the same...
We don't really do that. We don't let the option for CRI in. That's baked in by the image for the provider. So we do a lot of optional specifications. So like if they want to do that, there's custom mechanisms to allow them to do image provisioning or machine provisioning, however you want to call that. And that's part of that process and not necessarily in the API proper. It is in the API via that extra mechanism that I don't particularly like, but it's not common across all providers.
Well, if you're using kubeadm to init and join, like or at least for init, do you have to, I don't remember, do you have to tell kubeadm which CRI you're using, or is that just covered by what's in the image?
It's usually covered by what's in the image, but it's an optional parameter if you want to override.
Are you able to specify remote CRI, Tim?
Remote CRI?
I mean, are you able to support a kubelet whose runtime is equal to remote?
Yeah, so today I think you actually need to specify non-Docker CRI in the kubeadm config.
The Docker is like the default, right? And it doesn't try to discover anything else.
So I think it is something that we need to consider, but I don't know if it's something that we need to consider at this point, because that goes into kind of like the implementation details of how we implement, you know, the configuration and the bootstrapping.
You might want to make a generic catch-all, which would be like cluster API must allow customization for foo.
Seems reasonable. I mean, are we thinking about stuff beyond container runtime?
I would, like, if you think container runtime, I would include image FS management, size of overlay.
You say basically customization of node and image, node or image, machine, node, or image.
Are those things kind of translate to kubelet flags and kubelet config type stuff? Can we just say that?
No, it's more than that. It's configuration plus software deployment, right?
Right. Oh yeah. Okay. So now I see what you're saying here. Yeah. Okay. So yeah, generally that seems plausible because like sometimes people need to run this one specific command or something like that. You know, I had a use case recently in IKEA Schedule. They asked for a way to disable hyperthreading, and that has to be done before kubelet starts. And it's just like an echo to sysfs.
So I think that is a good thing just to go back and highlight the use cases doc. Like if you've got something like, I need to disable hyperthreading and it has to happen before something else, like throw it in the use cases.
Okay, yeah, sure.
So around the upgrades one, Derek, was there anything else or anyone else on this in particular?
No, no.
Okay.
I have a question. Is it important to separate control plane upgrades from node upgrades?
So the requirement here was meant to be super generic so that there is orchestration around how do you upgrade a Kubernetes cluster? Oh, I need to do the control plane first, and then I can go do the non-control plane nodes. It's meant to be a generic requirement to cover that.
Okay, so in the use cases where we would expand on whether or not, like potentially I have two different pools of nodes that might be running two different versions.
Yeah, and this also is not prescriptive about in-place upgrades, rolling replacement upgrades. That is left to the use cases. And then as we refine the use cases and we break out into the KEPs for the individual features, we'll have a lot more discussion around those individual items.
Okay, thanks, Andy.
Okay, so I added this one just now about customizing the machine /node/image. I would say if people want to put in bullet points about things that they're interested in customizing as possibilities, please do so. Next, we must be able to provide sufficient information for a consumer to access a provisioned cluster's API server. Thinking here is if cluster API provisions a cluster, presumably the person who asked for said cluster will need a kubeconfig or similar mechanism to be able to talk to the new cluster. And again, nothing here is implementation details, so how it provides that information and what it looks like is left to further discussion. All right. Cluster API must be able to display the Kubernetes version of a node it manages. So this is if we are provisioning machines or pods that represent Kubernetes, we want to make sure that with using cluster API types, we can figure out what version of Kubernetes is running on there, or other distributions. And Jason, is there more that you wanted to say around this one?
I don't think so. It just basically enhances that there's generally an implicit machine to node linkage. Well, not really necessarily.
Or whatever that ends up looking like. But this is more than just kube control get node. This is, there's a machine or some cluster API data type that we want to be able to look at and figure out what version that machine is running.
So in the non-pivot case, that means from the cluster API, you can see all the nodes that it's provisioned in any given cluster and the versions that's running on it.
I missed the first couple words you said.
In the non-pivot case, so right, you've got one cluster API managing 50 clusters. You can see them all in one place.
Yeah. Okay. Next up, Cluster API should be able to apply configuration changes to managed components. This could be things like changing the log level of the kubelet or something else on the system. This is intentionally vague because I think we need to talk more through use cases. But I know that I've talked with Derek about being able to do configuration changes that happen after the machine is provisioned and configured. So I would again ask that that you all add use cases in the other document for this sort of thing.
Why is this explicitly not out of scope? That's the thing I'm trying to understand. Like, management of the machines after they've been deployed is not a life cycle thing. Like, they're not upgraded. They're not. You're doing sort of standard management. That's
Tim, to clarify, since Andy noted that I had raised this with him, in a prior discussion that Andy and I had, I was trying to understand what ongoing administrative tasks I might do through the cluster API or behind the cluster API. And so some examples of those tasks would be a user is trying to analyze what is wrong with the machine. Like the node keeps going not ready every 10 minutes, 15 minutes. And natural questions that come up then are, can I get the container runtime logs for my runtime? Can I increase the verbosity of kubelet logs or any of those actions? And so if that's out of scope, that's fine.
Yeah,
I just wanted to understand where the scope boundary was.
that particular one, all the things you mentioned are out of scope explicitly. So
you don't think that changing the kubelet log level is something that's relevant here?
Not with dynamic kubelet, no. So dynamic kubelet configuration exists, and so does the modified kubelet configuration. So if they want to, they just basically use kubectl to adjust the component config.
Yeah, so dynamic kubelet config has probably varying levels of success right now, and not all aspects of kubelet config can be edited in dynamic kubelet config.
And also the static manifests, you can't kube control edit those to change things.
Yeah, but the whole purpose of cluster API is immutability. So this is mutating. So if you want to, you could restamp and redeploy new images and migrate your workloads off. But the fundamental premises inside of cluster API are to be immutable.
So I didn't think we had an opinion on in place or not, but if we're just saying granular configuration of components is out of scope, then that's fine.
Yeah, we are.
Do we think it's plausible for a provider to have a solution for this?
They could. There's nothing that, I mean, just because it's not in core doesn't mean that a provider can't do whatever they want. Like, that's part of the whole flexibility of a provider. And to be honest, I would argue at probably a high enough level, this is part of the component configuration working group's responsibility. Like they're trying to make the dynamic kubelet configuration and other configuration for other components as well be more programmatic via APIs. And Lucas and Mike Toffin have been working on this for a long time, and they're making good progress. So I would totally punt it on the scope.
Yeah,
I would say in general, we don't want to do things that can be done by other, but in other ways. That gets back to the duplicative.
Yeah.
Functionality.
Yeah. So I was wondering, like, there's this slightly different concern. Like, let's say I have like what do we call it, a machine set, right? And in a machine set, I'd like to, I don't know, change, like add a label to each of the machines in a set. Should that be our concerns? Because you could technically call like the node API and do a loop around that. But because it's a machine set, it would make sense to be able to sort of have a group operation.
Yes, I think that's totally reasonable, but I think that's kind of a separate condition than mutating the actual images. So that's a separate thing where we're dealing with the components as part of the API, and that is totally within our purview. But I think mutating the images that can be done out of band via another tool or another process or another system, I don't think we should take ownership of that stuff.
So earlier, Tim, I had asked a question. We're talking a lot on container runtime and kubelet because that's where Andy and I had an initial conversation. If we extend to other components, does this include the CA for the Kubernetes API server or CAs for etcd? Or does it, I guess, what are your thoughts there?
So I think that we have seen that at least two different cluster API providers are both dealing with CAs and certificates for etcd, the front proxy, and one or two others. I think that we probably should have something around certificate management as a should. I don't know what the wording would be, but I would hate to see multiple implementations of certificate management.
So we at least need to be involved with certificate management from the bootstrapping perspective. We don't necessarily have to take ownership of certificate management afterwards.
Yes.
Agreed. Yes.
Yeah, which sounds similar to the node mutation that we just discussed, right?
Yes.
So
like,
if I have a capability where my provider is auto-rotating the Kubernetes API server CA and distributing that CA to components in my cluster, is that outside the scope of the interface described here?
If you're doing it a custom way, then yeah, I think that's totally out of scope. There's nothing that prevents us. Eventually, over time, we might want to distill a common best practice, but it would not be. I struggle with this one in particular. CA is a little rough because a lot of people have very opinionated ways that they do it. So prescribing a mechanism gets really weird.
So I'd like to see us divide provider into multiple concepts where there's an infrastructure provider that purely does infrastructure. And if we want to have an API or a provider for Bootstrap certificate management, I think that's appropriate, and we can have a reference implementation and people can switch to different ones. But I really want to decouple this idea that the AWS or the Azure provider are responsible for certificate management and cluster bootstrapping, because there's nothing provider specific about it unless you're leveraging
certificate management. It's baked into kubeADM, right?
Right.
So like it's baked into your basic provisioning tool, which is part of your image, right? Typically.
I just want to know if we're distinguishing bootstrapping a CA versus ongoing rotation of said CA, which many providers will do at a different cadence than even normal install and upgrade. And so just
If I might, I think the reason this particular example is particularly hard is because we don't have a clear Kubernetes API for CA rotation yet. And like node labels, for example, felt easier to describe. Like we were able to like say, well, we should define our API such that you can do like the different management scopes based on how you're managing the nodes. If we think that that is important enough, some group should create that API for the CA and CA, I just realized the acronym, for the certificate authority, and then cluster API should work well with that, I would say. But this is a particularly hard example because there is no such API right now, and I don't think we necessarily want to define that API in cluster API. So,
I would agree.
I agree that I'm sorry. I agree that I don't think it should be defined, but I think providers should have a broad amount of leeway for how they manage some amount of security posture for the cluster they create. And that's kind of how I would phrase it.
I don't know if anyone wants to take a stab at trying to distill that one, but I think the bullet point we originally highlighted about the node managed one can probably go away.
Which one, Tim?
I think Andy already removed that bullet point.
Okay.
Oh, the should configure. Should be able to make configuration changes. Yeah, I got rid of that. Okay, next up is cluster API must take remediative action if Kubernetes cluster infrastructure is in a degraded state. So this is the idea, for example, that an EC2 instance terminates for whatever reason, and there's a cluster API machine that is associated with that EC2 instance, so there needs to be corrective action to either delete the machine and create a new one, or keep the machine, spin up a new EC2 instance, or whatever's appropriate. And this applies to cluster infrastructure broadly, so that providers can deal with things like fixing firewall rules if they get messed up, for example.
So is this saying that the individual elements of a cluster infrastructure is not going to be defined, is not necessarily defined at a granular API level, like the amount of NAT gateways or ELBs or the configuration of your VPC?
So I don't think this is getting into the implementation of how the infrastructure is defined. The main point of this one is so that if we are managing infrastructure for a user, we've created it, they expect us to manage it over time, then if it goes into a degraded state, then we should repair it.
But is that one question I have here too, which kind of boggles me, because we're talking about the core cluster API. This seems like a provider-specific detail.
Well,
is the core going to manage this? Or is
to get into implementation details a little bit, what we were thinking is that we would have a set of APIs like create, validate, reconcile, and delete that would be scoped per thing. So you might have network as a thing, firewall, what else did we have? Load balancer, if there's a load balancer that's sitting in front of the API server. And so cluster API could have these concepts generically, and it could periodically call validate on every single cluster, and the cluster would, or it would, for a cluster, it would say, go validate your network, go validate your firewall rules, go validate your load balancer. And then that would be an extension, webhook, gRPC call out to a provider specific implementation to go check the VPCs and the NAT gateways and everything.
But that implies, Andy, that the definition of the data center topology is a aspect of the cluster API.
Yes, insofar as it would be really high level, like network for a cluster.
I'm speaking for a lot of users in the world. I assume like something as basic as how you manage a VPC is widely variable, where many enterprises, for example, would say you can create a VPC, and many would say no, that is strictly managed by my my enterprise rules.
Yes.
Like firewall rules. All of these things are a little worrisome, because this is the major. It's one thing to say, to have a provider that says, I don't know anything about your infrastructure, just tell me it's okay. And it's another thing to say, let me define your infrastructure at that granular of a level.
Right. So there's a concept of managed stuff that's managed by Cluster API and stuff that is bring your own. So if you allow Cluster API to manage your networking and your firewall rules and your load balancer, then I think it's appropriate for Cluster API to be able to validate and reconcile those things. If you bring your own VPC, then we're not going to touch it.
Yeah, but in that case, it may make sense to send out an alert or somehow indicate that something's gone wrong, which would classify as a remediative action potentially. I mean, in a sense, we send an alert for somebody else to take an actual action, but
we may be able to do that in some cases, but not others. So we can't necessarily assume that we can introspect the environment if they're passing it in.
Yeah, if we don't have permission to do it.
This calls out a more granular requirement, Andy, which is if you have a component that can create networks, can create compute, can create firewall rules, can create all of these aspects, in particular infrastructures, then you run into issues about how do you least scope permissions to those tools that can do those actions, how you mint credentials for those tools that can do those actions, and how you manage the life cycle of those credentials. This is an area that I think is very dangerous to try to take on in a prescriptive manner versus just say, a provider gives me an infrastructure and I don't try to program it afterwards.
So the problem that we have there, though, is that if somebody is consuming the upstream Cluster API project directly, then they don't necessarily have a way to actually upgrade and manage those clusters over time.
I think that's a matter of asking.
If you implicitly.
Well, I guess that is maybe that is a problem, but I think this is earlier when we discussed a compute API, we talked about Terraform and not wanting to redo it. This bullet point sounds like Terraform to me.
So Derek, this is there is going to be a set of infrastructure components and pieces that Cluster API providers will create. They will create EC2 instances, they will create VPCs, they will create security groups, whatever else you do in AWS. And assuming you are allowing Cluster API to make that stuff for you, I don't see why you wouldn't allow Cluster API to reconcile it. It's not Terraform. It's
all those details are completely provider specific. So
yeah, but it's hidden by a hook. I think what's missing here is the logistics behind when it says take remediative action, it's basically calling out a hook for the provider specific implementation to do all the work. So it's the provider that actually provisioned the details, but it's not Cluster API proper that's doing the work, it's the provider.
I think that's key, Tim, and I would not disagree with that in principle. I think where I struggle is when Andy said not to want to get into implementation detail, and then we got a little bit into implementation detail, which is I do not believe when we talked about should Cluster API say I have a single node control plane or HA control plane or regional control plane, the moment you start also saying Cluster API is prescriptive about how I construct my regional control plane data center environment, versus it's hidden entirely behind a particular provider. Like these are tension points where you'll struggle to say that How do I reuse a particular provider broadly or not? Like, what amount of variation you provide? And I think you'll run into issues on just how you manage my credentials. Like,
I don't think we're saying that we're going to be prescriptive about how you create your network. I think Andy pointed this out. It's like we're trying to like make this very high level and very generic. And as Tim pointed out, this will be a hook that we will call to, and providers like can provide their own implementation for it, and any implementation. Like Cluster API doesn't have to know, it won't know how that's implemented at the end of the day.
If the hook is at a granular level of a firewall rule, then I think...
But we can always have that as a no-op, and the provider can decide to either fill that in or not.
But then how is it trusted? Like if I set up firewall rules to enforce...
Hold on, Vince. Let Derek ask his question.
How is that trusted as an API consumer then? Like if you're saying I give a provider a firewall rule definition and it's ignored, and then I trust that to depend on my network policy configuration.
So I think the distinction is Cluster API is not telling the provider this is the firewall rule. Cluster API is telling the provider, go configure the firewall for this cluster with no information other than you need to configure a firewall, and it's up to the provider to configure.
Well,
it would have a spec.
So I think there would be some sub-level of information that needs to be passed in. But at the end of the day, we're starting to talk about like hypothetical implementation details.
Yeah, I agree.
This is some that hasn't even been fully fleshed out and designed. This is some that hypothetically talked about, assuming we can agree on the high-level requirements.
I guess what I would wonder here is, rather than say must, which implies that the cluster itself is providing directed guidance on how to maybe remediate. Maybe it would be cluster API providers should ensure that they have a stable and resilient infrastructure. But I really get wary when we're looking to program how that stable and reliable infrastructure is enabled.
So one of the things that we were trying to capture with this is like, if your machine goes poof, you know, Cluster API and by proxy, the provider should be able to replace it.
Yeah, it's kind of already exists today in some ways, shape, or form, to be honest. So I think what we need to do is, I think we're missing like pictures, right? High-level pictures to go along with some of the, and refinement of the language.
I think we're also missing differentiation between the APIs that will be part of Cluster API and the functionality that will be part of the reference implementation and the functionality that is a responsibility of the provider. And
I think that could be part of the picture, though, right? Like,
sure. But I mean, each of these requirements actually applies differently to those different things. Some of these requirements are for one of those things, some of them are for a different one of those things, and it's a little bit fuzzy now.
Yeah, I think it's fuzzy if you're coming in fresh, if you've been doing this for a while. You kind of have the internal vocabulary so you can see what the future is. But I totally agree that anyone coming in fresh would be like, what? So
yeah, I think, I don't know the scope of this, but having a distinction for these goals between Cluster API and a provider implementation would be very helpful.
So something that I'm missing in this conversation is that I understand the idea of this reconciliation, but I think should this be in this provider-specific description of the cluster, and we just pass that to the provider, say just be sure this is right, and tell me back what is the actual state of this?
Yeah,
because MC description, like we don't know what is there. I mean, we don't know if they're a firewall. We don't know if they're a VPC because that depends on the implementation. Just say when you create the provider said this is my this is how this cluster looks in my infrastructure, and we later on say, is this still valid? If not, tell me what it is.
Yeah, that's
so
something like that.
One thing.
That's what I have
one
here.
thing to keep in mind, if we are specifically talking about firewall rules, then there is some that is going to be there's some input that's going to come in from Cluster API directly because the configuration that you're asking for is going to impact what config is needed. So I don't think it's just as clear cut as this is always going to be.
Well, I think there's a distinction between whether it's coming from the cluster API and whether or not it's opaque to the cluster API, because that could be completely defined in the provider specific config section, and the cluster API itself doesn't need to necessarily understand or interpret any of that.
Is there a particular way to scope this such that it's just applying to the nodes? I mean, it seems like we're talking about the sort of cluster resources, but the line item here is specifically about replacing a node in an unhealthy state.
Well, it's also, if we can get to a place where we have very loose generic APIs for cluster networks, cluster load balancers and whatnot, then it's broader than just nodes. And I do want to reiterate that this is not saying that cluster API is informed in any way about what firewall rules should exist, what network should exist. It's more the generic concept of networking and firewalls. And I have a little pseudocode here that basically is like, let's go look at all the clusters, and then for each cluster and its provider, let's validate the network. And if there's errors, then we're going to ask the provider to reconcile the network. And that assumes that the provider is in charge of creating the network. If it's not, this won't happen. If it is, then the provider, whether it's AWS or some other one, can go do its own thing to make sure that stuff looks good. This is not about trying to make cluster API informed about there's 10 different firewall rules that are necessary.
Yeah,
well, I think why do I need the cluster API to remind me to do that?
What's that?
Why do I need the cluster API to remind me to do that?
Because the cluster API was what provisioned the infrastructure in the first place.
I think
but it didn't, because the infrastructure definition was not defined or is not yet clear. Like, that's all behind the provider.
Yeah, the provider should do the reconciliation on that kind of stuff. Like, why even add the cluster API into that mix? It doesn't know how to do any of it. So all we need to do is say, provider, your config changed, reconcile this.
We had a terminology thing in the first hour. Cluster API here does include, it's the project. It is not specifically like types.go. So that would be, I think, under that umbrella.
I just, if there's not going to be a definition of the infrastructure that's fed as input to the cluster API, then I don't know.
If your provider does not define it, then yes, you would not reconcile it. But I think
I don't think but here we're talking from a high level that the cluster API may call a hook in some implementation, and that implies that the cluster API itself knows that there's a high-level networking config section that it itself needs to reconcile and then hand off the actual work to a third party. And I don't think that's really optimal. There should be no high-level network config. That should be all provider-specific. If I should be able to say I want Kubernetes cluster version 1 and I want 3 nodes, and the provider knows exactly what it needs to do for that. And if there's a provider-specific network section that I need to tell it, that would be an opaque provider details that the provider would reconcile.
We can cover that. We're talking about goals, right? But we can cover that in.
I agree that we don't need. I mean, I'm really confused. Why, in this particular case, we need to know the specificity? I can buy the idea, even if I don't agree fully. I agree that I don't know why we need to call the provider to reconcile. But I find with that, as long as it's something which is opaque. I say, you tell me when I created the cluster, when you provide the cluster to me, you told me that this is how it looks like. Now check it. But going into network, I mean, that's the part. I mean, why do we need to get in the finer grain of detail of what the cluster is? That's the part really, I don't really get it. Sorry.
So if we talk about firewall rules and we talk about we have to be able to configure a CNI for a user to have a usable cluster, the CNI provider of choice is going to dictate specific ports and protocols that need to be open between nodes for that CNI communication to be able to happen.
One thing that might help here is that we have seen like repetition across providers in logic that like determines the network and firewall rules and load balancers, as we were saying. And as Jason was saying like one of the things that I think might help understand is like, well, first of all, like we're not saying that like every provider has to do this. This is like just an effort to generalize some code base and also like kind of tie up like more things together upstream. But it doesn't mean that like a provider has to adhere to these hooks or that has to provide an infrastructure configuration. But we have seen that it has been useful, for example, in the AWS, Azure, and I've seen some repetition also in the GCP provider and vSphere to kind of like generalize the network configuration that will be used for the cluster. And that's all we're trying to do. We're just trying to, like, at the end of the day, like reduce duplication of effort between providers by providing like a little bit of more code upstream and more generic code upstream.
Well, I also think that I believe that there had been a request to make the cluster object optional in Cluster API. So regardless of remediation, I am curious, because I think it relates here, if you don't have some sort of cluster or an API related to that cluster to get the infrastructure provisioned, how do you get things like a VPC set up if you're, like, the first time you're interacting with Cluster API is you say, please give me a machine?
So I think we're mixing some concepts a little bit. I agree, when you create a machine, you need to describe a context for where that machine is created. I do not believe that implies you need to describe the entire data center.
I agree. I think that's a mix.
I don't think nobody said that, though.
I think that's I think the thing is, anything we create, we should Kubernetes style, we should reconcile. If we don't, but we're not saying we're going to create the world.
Yeah, and I mean, some implementations may not have a networking component whatsoever, right? I mean, at least as far as the user is concerned, they may not need one. Like in GKE, I don't have CNI, and there's like just a name of a network that I use, and sometimes, you know, you could build a provider on top of that would, you could imagine you could build a provider on top of GKE that just assumes some default network, and that's the only choice that you have. And having this discussion now, it's just that, I mean, I think the misleading part here is that people think that they may need to have to do this, and this may have to be a requirement for all the providers to have some kind of network and some kind of reconciliation for it. And I think the outcome of this is that actually it's not necessary for a provider to have such a thing, right?
Yes, I think that's correct. And we're already like over time, so yeah, I mean, we have two more points if we want to continue, or we can do another time.
I think this is worth some additional discussion. I know, I think let's pause on it for right now and have some time for individual reflection. I'm going to jump to the last one because I hope this one has no discussion. Cluster API must support all operating systems in scope for Kubernetes conformance tests. So Windows, Linux, you know, as stuff gets added. And then
on that point, that includes mutable and immutable. So like COS is immutable, correct? And obviously, speaking for Red Hat, CoreOS is immutable.
Yeah, it was more about Windows and Linux.
Okay, then maybe we should clarify the characteristics a little bit.
Just as in the kind of platform OS type thing, yeah. Like Kubelet can run on Windows in Cluster API, you should be able to have Windows machines that run kubelets.
Yeah.
Okay, can I have an immutable operating system though, where kubelet is able to run?
That sounds like a separate concern.
It sounds like a good use case, though. That should be linked to this requirement.
I didn't understand that. There were people talking over each other, but
I was suggesting to add that as a use case and link that to this requirement. I think that's completely okay to add it.
Okay.
Is this a case of support, or would this be better phrased as agnostic to the operating system layer?
It's really about, like, if Kubernetes can run on Windows, Cluster API must be able to provision a cluster on those platforms that, you know, Kubernetes supports.
Yeah, I think it's simple enough. We would probably wanted to have a few more specific things about operating systems to cover some of the other use cases, like different styles of OS management and stuff like that. But some of that may fall into the node bootstrap or the image concerns. This is more like Windows, Linux, and
yeah, that's what I'm just trying to think of what that would require of the cluster API to differentiate between these different operating systems.
It's not necessarily differentiation. It's more just you need to be able to deploy on Windows in addition to Linux. So this came from the other document where it was worded as something like Cluster API must be able to deploy Windows nodes.
Anyway, folks, I think so.
See you, Ilya. Thanks.
Yeah.
So we can wordsmith that one. The one remaining one is Cluster API must provide the ability to receive the health status of a Kubernetes node from an external source. And I'm going to let either Nadir or Jason describe this one.
Thanks.
Nadir, if you're muted if you're talking.
Yeah, I haven't got. Yeah.
Yeah, so the goal behind this one was to basically say that we don't want to own higher level health status outside of bare minimum status and reconciliation of that status. Instead, we should be able to accept input from the node problem detector or other external sources to determine node health and how to take action on those nodes.
So from my perspective, this is where the details of how this gets implemented are important. And if the definition of a compute layer is distinct from the definition of an incantation of a node, I think that the choice that's made here may impact what types of common tools would be built outside of this project in Kubernetes generally. And I would like to be able to build a add-on to handle node repair in Kube, independent of or not necessarily tied to this particular project, right? I feel like we have APIs today in the cloud provider that let me ensure a load balancer. We have APIs today in the project that let me inquire about the health of a machine. I think this is an area where I think it's worth asking if the cloud provider interface had a call out to deprovision a host or provision a host, we could build this tool in a install agnostic way.
So
which I think would have broad applicability across the community generally. And this is an area where I'm wondering, like, what amount of add-ons is this project looking to take on?
So we're not trying to build this tool. We're trying to be able to leverage existing tools in this space. So like we need to know, like in the case of talking in machine sets and machine deployments today, if we're going to maintain those over time, ideally, if a node becomes unhealthy, we would replace it instead of just leaving an unhealthy node kind of sitting around. So we need to be able to accept that kind of node health for that use case. But additionally, if I provision a cluster with Cluster API and it comes back and it says, here's your cluster, I should be able to inquire on that cluster as to kind of the status of that cluster. Is that cluster healthy? Things like that.
Yeah, I don't disagree with any of the goals you state. I think they're goals across the entire Kubernetes project. And all I'm trying to communicate is that the way that we choose as a Kubernetes project to implement that goal can make it that implementation is universal versus only usable if built or consumed by this project. And so I would prefer that like we could work together to build that tool in a universal manner. And I think when we get to discussions of KEPs and issues like that, I think that's when we should probably talk through it. But I agree with the goal. I would want that in my cluster as well.
To just see if I understood correctly, like you're suggesting to like make this tool as generic as possible outside of Cluster API, but then later on decide if Cluster API should implement the hook to the tool instead of vice versa?
I'm suggesting like, GKE has a capability that says node auto repair. I'm sure AKS, EKS, and any other provider would have that same capability or aspire to have it. And I think as a Kubernetes community, I feel like there is a opportunity for building that capability in a mechanism or approach that could be adopted by EKS, AKS, or any of these other vendors, independent of their choice of consuming Cluster API or not.
And contrary, does that mean annotating the node, for example? Because I think we could all get behind that.
Does that mean annotating the node or not? I think it matters like what we view the scope of the cloud provider interface in Kubernetes as meaning. And so today we have callouts that let you ensure a load balancer exists or to delete a load balancer in the context of your cluster. If we had a callout in the cloud provider interface that allowed you to create a piece of compute or delete that piece of compute, we could build this tool agnostic of any install choice.
I think this is, so I think as a point of order, I think that we're not adding anything to the cloud provider. We're taking the cloud provider out of core and we are building an API. The extensions that we're doing are in subjects like this one. So if we were to build that API, it would look a lot like Cluster API, I suspect, right?
But I know that we're taking the cloud controller managers out of core. I'm suggesting you could build this component in the cloud controller manager. And I'm suggesting this tool has overlap with the node lifecycle controller, where if you build an API that allows you to provision and deprovision compute in some location, then you'll want to integrate with the node lifecycle controller to know when it asks, does this machine exist or not, so that I can detect a zone or region failure, that the right thing happens.
But like, how does this relate to this point that we're discussing? Because it seems like this could be an extra with the degraded state that we have discussed before. This is just to have a hook to say, is this machine healthy or not? That could be literally anything, any tool.
Is machine but is machine health tied to the node condition, or is it tied to, is the machine terminated? Is it network partitioned? Is it?
That depends on the implementation detail. Like this is just pretty much saying like, do we all want like cluster API to call a hook saying, can I get the health of this Kubernetes node?
Yeah, and like I said earlier, I don't disagree with the goal. I think the goal is
okay.
good.
I mean, yeah. I'm just saying we should probably wrap it up because it's like.
Yeah, I just want to be clear. I don't disagree with this goal. I think the goal is fantastic. I think the way it's chosen to be implemented should have broader discussion.
Perfect. Yeah. And let's leave that when we go down to the implementation detail. I'd love to continue this discussion.
Yeah. So I want to thank everybody for participating in one or both of the sessions today. I know it's been close to 2.5 hours. So I think we should stop now. And please review the document and comments, as well as add your use cases to the other document. And I will send out a doodle for a time to have a follow-up discussion next week. Thank you, everyone.
Thank you.
Thank you. Bye-bye.